This is the screencast for section 3.5, example 2, solving an exponential equation. So this is a different situation than what you've seen in the past because we are dealing with, well, I'm going to rewrite this so it's easier to see, but it's e to the x minus e to the negative x all over 2 equals 5. So you have e to a positive power minus e to a negative power. Well, I mean, how do you solve that? So first step is you can multiply both sides by 2. And then if you remember, e to the negative x is really 1 over e to the x. So to get rid of e to the x out of the denominator, I'm going to multiply everything by e to the x. So e to the x times e to the x is e to the 2x minus, now e to the x divided by e to the x would be 1, equals 10 e to the x. So in order to solve for this, I have to set it equal to 0. Now, e to the 2x minus 10 e to the x minus 1 kind of has a familiar pattern to it. This is actually a quadratic type shape. If you your exponential properties here, e to the 2x is e to the x really squared. So what I can do is off to the side, I can say that u is going to equal e to the x. So I'm identifying this one letter u to be the expression e to the x. So I'm going to say that instead of e to the x squared, I have u squared minus 10, and then e to the x is u, and then minus 1 equals 0. Well, now this is a lot easier to see, and I can use quadratic formula. So u equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a is how you solve for x. Okay, so here's my quadratic formula. So now 104 is 4 times 26, and 4 has a square root. Its square root is 2. So this is 10 plus or minus 2 square root, let's see, 26 is still going to be left inside there. And then now, since 10, 2, and 2 are all divisible by 2, I can simplify this to be 5 plus or minus the square root of 26. But remember, x doesn't equal 5 plus or minus the square root of 26 like all the rest of the times you've done quadratic formula. It's actually u that equals 5 plus or minus the square root of 26. So u, which we said was e to the x, equals 5 plus or minus the square root of 26. Well, here's the problem. E to the something will always be positive. 5 minus the square root of 26 will be negative. The square root of 25 is 5. So if you subtract the square root of 26, it's 5 and a little bit, which is going to make this a negative number. So e to the x has to equal 5 plus the square root of 26. So now I have to solve for an exponent. Well, what finds exponents? Oh, that's right, logs do. So I'm going to change this to log form. This is log base e, because the base of my exponent is the base of my log, so that's really natural log, of 5 plus the square root of 26 is going to be x. And that would be an exact answer. If you wanted an approximate decimal answer, that's about 2.31. And of course you can check that by plugging it back in. E to the 2.31 minus e to the negative 2.31 over 2 should be 5. The directions for the Now Try problem number 31 are very nondescript. They say solve each equation by a method of your choice, then support your solution by a second method. So what I'm going to do is I'm going to solve this by hand, and then I'm going to solve it graphically. Sometimes you might be able to solve it by hand 2 different ways and make sure you got the right answer. Sometimes you might be able to solve it by hand and then check it, plug it back in. This time I'm going to solve by hand and then check it on my graphing calculator. All right, so I'm going to multiply both sides by 2 first. So I've got e to the x plus e to the negative x equals 8. And then, like the last problem, I'm going to multiply everything by e to the x. And because I remember how that goes, I don't need to show every single little step in there. I can just say this will be e to the 2x plus 1 equals 8 e to the x. Subtract 8 e to the x from both sides, and I have e to the 2x minus 8 e to the x plus 1 equals 0. I don't need to use u. You absolutely are welcome to use u. But in this case, I know that e to the x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So e to the x is going to equal 8 plus or minus the square root of, now I notice in here 64, the square root of 64 is 8, so since we're going to be subtracting some of that, I might have two answers here. So now that I have e to the x equals 8 plus or minus the square root of 60 all over 2, I need to solve for the exponent, and the best way to solve for exponents is logs. So I'm going to, in this case, do something a little bit different. I'm going to take the log of both sides. Now, if I'm going to take the log of both sides, what do you think my base should be? Hint, hint, the base of your exponent is e. Yeah, I should take the natural log of both sides. Therefore, I have log base e of e to the x on the left, which simplifies to x, and then that equals the natural log of 8 plus or minus the square root of 60 over 2. And so that I have the decimal approximation for that, that's about 2.06 and negative 2.06. So now I said we're going to do this by a second method, so I'm going to graph in y1 e to the x plus e to the negative x all over 2, and then in y2, 4. And then since I know my intersections are supposed to happen at negative 2 and positive 2, and then I'm looking for y equals 4, I just did zoom 4 and then changed my y max to 5 so I'd be able to see my line y equals 4. And I've got this graph here that I can find my intersections. And since I got the same x values for my intersections as I did when I solved, I know I did this correctly.